This problem isn't too bad of a velocity problem, but there's a little setup involved because it tells you you have two things moving at the same time, right? So it says the runner is L distance from the finish line. The bird begins flying. And the bird is going to reach the finish line, turn around, and come back to the runner. And so the runner's only gone a little bit of distance. And the question is, what cumulative distance does the bird travel? So the bird is traveling a distance. Let me do the bird up here in blue. The bird travels here, and then the bird is going to come back to here because at some point right here, that's how far the runner goes in the same time that the bird goes that distance, right? So this is the distance the runner goes, and forwards and backwards is the distance the bird goes, right? So I'm going to call this distance x, right? So let's say runner distance is x. And the distance from the runner where he started to the finish line is L, right? So then I can define how far the bird went by doing L, because the bird went forward L, right? This distance here was L. And then the bird came back this distance here, which is the difference between L and X, right? So see, here's L, here's X. So this leftover distance here must be L minus X, right? So that's going to be how far the bird runs. So the bird total distance is L plus L minus X. All right. So now that I've got that, I know the distance of the bird. I'm going to call that dB. That's L plus L minus X. Right? And I know the distance of the runner is X. So I'm going to call the distance of the runner dr. So that's X. And I also know that the bird is so many times faster than the runner. Right? So my bird is 2 times as fast as the runner, right? So I know whatever distance the bird went, because the bird is going 2 times faster than the runner, he's going to cover twice the distance, right? So the bird, I can say the distance of the bird is going to be twice the distance of the runner because bird is 2 times faster. So maybe your bird is like 4 times faster. Then your bird would be 4 times dr, which is the runner. If your bird was 5 times faster, then your bird distance would be 5 times dr, right? It's not that complicated. It's just however many times faster, that's how many times farther he's going to go. Okay, so now if I take this and I substitute in, right, I can say distance of the bird equals 2 times distance of the runner. Okay, I'm going to sub in the stuff I know. Right, so the distance of the runner is x. So I'm going to plug x in for distance of the runner. And I know distance of the bird is this whole mess right here. I'm going to plug that in for distance of the bird. So I'm going to have L plus L minus x equals 2x, because x got plugged in here, right? And from here, I can simplify, right? So let's see. So L plus L minus X, L plus L, right? I don't really need these parentheses because the addition and subtract, well, I'm going to subtract that and it doesn't matter. So the L plus L is 2L, right? So I'm going to say 2L minus X equals 2X, right? So I basically got rid of that parentheses. I can do that because it's addition and subtraction, right? If I did L minus X first and then added L, it'd be the same as adding the 2 L's and then subtracting X, right? Addition and subtraction, I can do that. So I have 2L minus X equals 2X. Oh, okay, I'm basically done. So all I got to do is move the X's over, right? So I'm going to take this X and move it over here by adding it because it's being subtracted. So 2L equals 3X, right? So what I did was I added an X to both sides. So that canceled it out over here. Now I have 2L equals 3X. And now what I can do is, to solve for x, I can just divide the 3 over. So that means 2L over 3 equals x, right? And because I just did this in terms of L's and stuff, but if you look, my L is 5 kilometers. So mine says this distance is 5 kilometers. So now I can just take, now that I've solved this, I can just take 5 kilometers and plug it in here, and I can get the number of kilometers my bird went, right? So that's going to be 2 times my L, it says is 5. So I'm going to do 2 times 5 divided by 3. 2 times 5 is 10 divided by 3. That's what, 3.33? So my bird went 3.33 kilometers in the time that the runner took to just go this distance, right? And so your numbers are going to be different, but it's basically doing the same thing, right? You have to make a fraction with how much faster your bird's runner is. Everybody should have this, right? You just got to look at how many times faster your bird is, and then you can plug in and solve with your L. Okay, and the second part of this is fairly easy, right? So the second part says, after this first encounter, the bird then turns around and flies from the runner back to the finish line and keeps doing that over and over, right? So what's happening is while the runner is going forward, the bird is going to do this. He's going to go back here, and now the runner is going to move up maybe to here, right? And then the bird's going to come back. And then the bird's going to go back to the starting line, and then the runner is going to go a little bit further, right? Maybe he's getting tired, whatever. And then the bird's going to come back here and then go to the finish line. You see what's happening, right? So the bird is going to keep flying back and forth until everybody's at the finish line. And this seems like, oh my God, that's a crazy calculus problem. But it's really not, because I know that my bird is 2 times faster than the runner, right? That's what my problem says. So if my bird is 2 times faster than the runner, then the distance for the bird is going to be 2 times the total distance for the runner, right? Whatever the distance of the runner was. So my runner went 5 kilometers, right? That was L. The runner is going to go 5 kilometers. That means since the bird is always traveling twice as fast as the runner, in the time it takes the runner to go 5 kilometers, the bird is going to go 2 times 5 kilometers. So my bird is going to go 10 kilometers in that time. Seems like a complicated problem. It's really not, because the key here is they're traveling at constant velocities. Constant velocities makes life easy, right? So not terrible. Just a matter of setting up a fraction and plugging in your values and solving.